So our lesson today is on using linear programming to crash a project. Recall that crashing a project allows us to reduce the amount of time that it takes for a project to be completed. Our goal is to reduce the length of our project at the least possible cost. So in order to do this, we need to work through a certain number of steps. I'm using the General Foundry example that we talked about in class as an example. The first thing that we want to do is we need to determine how much our crash cost is per week or per month or whatever that unit is. In the General Foundry case, we know that the normal time to complete task A is 2 weeks, but we could crash it to 1 week by spending $23,000. Activity B can be reduced from 3 weeks to 1 week by spending $34,000. Recall that a normal crash or a normal task would cost us $30,000. So it would cost us $4,000 more to crash it by 2 weeks. And then so on through each of these. So through the task H, we can reduce it from 2 weeks to 1 week by increasing our costs from $16,000 to $19,000. So we need to figure out what we need to do to crash this project and how much it's going to cost per week. The way that we do that is through a formula where we take the crash cost minus the normal cost, and we divide this by normal weeks minus crash weeks. So for this first one, I'm going to start this out with a parentheses, and I'm going to take crash cost minus normal cost divided by normal weeks minus crash weeks. So this is telling me that it's going to cost me $1,000 to crash this. So I'm just going to copy and paste this formula down through all of my tasks. And now I can see that crashing task B, I can crash it by 2 weeks. It's going to cost me $2,000 per week. Task C, $1,000 per week. Task D, $1,000 per week. And so on through to task H, which is $3,000 per week. If I were to do this manually, I would identify those tasks on my critical path and find out the least cost tasks, and then do some calculations. But what I'm going to do is use linear programming in Excel to crash this project. The next thing I need to do is to define my variables. So I have two sets of variables. I have a set of variables x, and I have a set of variables defined by y. And I'm going to let x, in this case, indicate the earliest finish time for each of my tasks. And I'm going to let y equal the number of weeks that each activity is crashed. So let's look at the x variables first. I basically have an x variable for every task in my project. So recall, in the previous step, I have 8 activities, 8 tasks, and so I set up one x variable for each of those tasks. I also have a x variable for the start of my project, and I have one for the finish of my project. So x start is when my project begins, which is most of the time week 0, and xfinish is the earliest finish time for my project. Now I have the same thing for my number of weeks that each activity has crashed. So the next thing I need to do is define exactly what these values are. So I know that each of my tasks has a crash time. And remember, in the previous tab, I computed that by subtracting my normal time by my crash time. So if my normal time is 2 weeks and my crash time is 1, I know that I can reduce this by 1 week. For task B, normally it would take 3 weeks. If I crashed it, it would take 1 week, so that's a reduction in 2 weeks. And so on down. Task G, the normal time is 5 weeks, the crash time is 2 weeks, so that's a reduction in 3 weeks. So that's the maximum amount of time I can crash my tasks. So I'm just going to stick those numbers in here. And for purposes of my project, each one of these is going to be less than or equal to that. So I can't crash my project more than this. I can crash it up to or equal to these numbers. In addition, my finish time in this particular project, I'm being asked to complete this project in 12 weeks or less. So my finish time has to be less than or equal to 12. My start time is going to equal 0. So let's talk about these x variables now. Remember that the x reflects the earliest finish time for each task. So if task A takes 2 weeks to complete, and it's the first task to begin, since it starts at week 0, it'll finish at week 2. What we want to calculate, though, is what the earliest finish time might be for a task if we crash it by the amount that we're allowed. So here is a formula that helps us determine what the earliest finish time of a project is. So task A has no predecessors. It is the first task in this project. So x start here is 0 because the task starts at week 0. And then, in order to figure out when it's going to be finished, we take the 0 plus 2. 2 is the amount of time that task A would normally take. And then we subtract whatever the crash time of that particular task. So if task A, we determine that we're going to crash it by 1 week, we could subtract 1 from that, and so task A would take 0 plus 2 minus 1, or 1 week. But we don't know the answer to this because we want the linear programming to figure that out for us. In order to insert this formula into our linear programming, we have to solve it so that the 2 appears or is set up to appear on the right side of our spreadsheet. So in order to do that, we need to isolate this and use some algebra to solve for 2. So that's what we're going to do right now. The first thing that we're going to do in order to start this process is we're going to move x start from the right side of the greater than equals sign to the left side. So the way we do that is we subtract x start from both sides of our formula. So what we end up with is x a minus x start greater than or equal to 2 minus y a. So we got rid of the x start on the right side of it because x start minus x start is basically 0, and we moved it over to the left hand side of this. So now the next thing we need to do is move this ya over to this side. We do the same process, except this time instead of subtracting it, we're going to add it because it's negative on this side. So we're going to add ya on the left side, and we're also going to add ya on the right side. So what we end up with is xa minus x start plus ya, and then greater than or equal to 2 by itself. So now we have the formula set up so that 2 is isolated on the right side of this formula. So we'll come back to this in a second, but think about this in terms of ones. In algebra, if there are no numbers in front of it, we consider this to be 1 unit. So we have 1 unit of xa, 1 unit of x start, and 1 unit of ya. Think of this as the same as 1 xa minus 1 x start plus 1 ya is greater than or equal to 2. Okay, so we'll come back to that in a minute. So let's start filling in this spreadsheet now. The first thing we want to do is take care of our objective functions up here. So we're going to fill in our formulas, and we're going to, along the top, put in a variable for each of our y's. So we have 1 ya through yh. Remember that y reflects the number of weeks that each activity has crashed. We also know that each activity or each task that we crash has a certain cost to it. So we've already determined that task A costs $1,000 to crash. Task B takes $2,000 to crash, and so on. So those are our crash costs. The next thing we want to create a variable for is the project start. Now, This variable has no cost associated with it, so we're just going to leave it at 0. Then the last part of this upper portion has to do with our x variables. Remember, our x variables are the earliest finish time. So Excel is going to tell us by the start of this what the earliest finish time is for each task. So I'm going to create an x variable for each of my tasks, and then I also am going to create one for finish. So if I do this right, because the assignment is to finish this in 12 weeks or less, if I do this right, when I do my solver, this should equal 12. So that's the upper part. What I'm going to end up with is a cost right here of the project. Now I'm ready to start my variables. And again, I need a variable for each of my constraints. The first set of variables has to do with how many weeks maximum I'm going to crash my task. So I'm going to create a variable for each of my tasks. I know that task A can be crashed a maximum of 1 week. So the first thing I'm going to do is I'm going to put a 1 to associate A crash max with my A task here. And then over here on the right, I know that task A can be crashed a maximum of 1 week. So I have to put in a less than here. So task A can be crashed, has to be crashed less than 1 week. So now I'm going to continue down, and I'm just going to do this part first, but I want to associate each crash max with the variable. And then I'm going to come over here to the right hand side and just fill these numbers in. And then carry these symbols down. So that's the maximum crash that I'm allowed to have. The next variable is my due date. My due date coincides with the finish of my task, and I know that my due date has to be less than 12. So I'm going to type a 12 in here, and it's still less than. Next, I have a start date. And the start date coincides with the variable project start. And the project start is going to equal 0. Then my next set of variables have to do with the constraints related to my x variables. Recall from our flow diagram that tasks G and tasks H have two predecessors each. Task G has task E as a predecessor and task D as a predecessor, and task H has predecessors of task F and task G. What that means then is as we're setting up our constraints, we need to set up two constraints for both G and H. So I'm going to type G constraint 1 and G constraint 2. And then the same for H. H constraint 1 and H constraint 2. Now, in order to set this up, I'm going to translate the formula that I set up here into my LP. So recall now the one for constraint A, we had set this formula up of 1xa minus 1x start plus 1ya is greater than 2. So what I'm going to do now in my LP, for my A constraint, type a 1 in for the variable ya, and because my formula has a -1 for the project start, I put a -1 here, and then I have a +1 for xa. And then all of this is greater than or equal to 2. So here I'm going to type greater than or equal to 2. So now I'm going to work out the same formula for each one of these. So for my B constraint, I'm going to have a 1 here, and again, because it's the project start of a -1, a 1, greater than or equal to 3. C constraint 1. In this case, my formula is going to indicate xa as a predecessor, and so I'm going to have a -1 for xa and a +1 for task C, greater than or equal to 2. Greater than or equal to 2. D constraint 1. Task B is the predecessor, so a -1 there, +1 for D, greater than or equal to 4. Constraint E, a 1 for E, predecessor for E is C, positive 1 for E, 4. F, positive 1 for F, of minus 1 for its predecessor of C, positive 1 for F, three. Alright, so now constraint G has two predecessors. So we're going to pick these off one at a time. Positive 1 for G. The first predecessor is task E, so I'll put a minus 1 there, and then a 1 for G, and then this is greater than or equal to 5. Second G constraint, again a 1. This time the predecessor is D. It doesn't matter which order you do these in. I could have done the predecessor of D first before I did the predecessor of E. But in any case, I'm going to add another 1 for the G, greater than or equal to 5. Constraint H, task H also has two predecessors. So the first one uses F as its predecessor. Mark a 1 there. Greater than or equal to 2. And then second constraint, a 1. This time the predecessor is G. And another 1. Greater than or equal to 2. And then my last constraint has to do with my finish constraint. So I'm going to type in finish constraint. The predecessor for the finish is task H, so I need a minus 1 here, positive 1 for my finish. And my task has to be greater than 0. That is, I know that it's going to take more than 0 days to complete this task. So now I have all my constraints set up. The next step now is to run the solver. So I'm going to click on Data and Solver. My objective is this first cell here. I want to select a minimum because I want to minimize my cost. By changing cells, I'm going to choose all these cells in my spreadsheet is row 3. And then my constraints are several. My first set of constraints have to do with the less than symbol. So my cell references start here, and then less than or equal to. And even though this is less than, it's the same as less than or equal to for purposes of our simulation. And then my constraints have to do with these cells. I add my next one, and this is this row right here for the equals. Add another one, and my final set are these last ones. You can see there is no option for just less than. It's either less than, equal, or greater than or equal. Once I have all that selected, I click OK. Make sure that unconstrained variables are non-negative. Make sure that the solving method is simplex LP. Click on Solve. And if I did this right, I should have a total of $5,000 to crash this. And if I come back here, I can look at these variables and see it say that in order to crash this to 12 weeks, I've crashed task E by 1 week and task G by 2 weeks. Task E cost us $1,000, and then task G cost us $2,000 for each of those weeks, which is what gives us $5,000. And I also can see here that indeed I have finished within 12 weeks for a total of $5,000.